All right. So today, what we're going to be talking about is how we can look at the last shifter of the production possibility curve. The production possibility curve, we know, looks at an economy and what they can produce. And then the one thing that we discussed last class and practice for homework were the three shifters of the production possibility curve. We know that anytime you increase the quality or quantity of a resource, you're going to shift the curve. So if there's an increase in quality or quantity, you're going to go outwards. If you're going to decrease it, you go inward. And same with the second shifter, which was technology. Any increase, you're going to go to the right or out. Any decrease, you'll go in. The third shifter isn't really a shifter, it's trade. And trade is going to allow two economies to benefit from trade. And that's kind of a topic that there's going to be reinforced in every economics class you get, that there's always benefits from trade. And this whole section is going to work to show how trade will allow us to consume or get more stuff beyond our production possibility curve. How can we make a point outside of our PPC curve become accessible? And to do that, we have to work through what's called absolute advantage and comparative advantage, because we have to figure out how two economies can trade and how it's beneficial for them. This is supposed to be one giant lecture in one day, but I feel like it's kind of overwhelming and the content is a little bit strange in that we're going to be talking about goods in terms of other goods. So instead of like the cost of a bagel being the production cost of a bagel being like $1, we're going to talk about the cost of a bagel in terms of another good we're giving up. So instead of opportunity costs in the form of dollars, we're going to talk about opportunity costs in the form of a given up good. So it makes your brain kind of hurt for a second, but I like to break this up into a 2-day instead of a 1 day. So last night in our reading, we talked about absolute advantage, comparative advantage, specialization, and trade. Today, we're just going to look at absolute advantage and comparative advantage. Next class, we'll apply that stuff to determine specialization and trade. The first part, just to review from last night, absolute advantage is when you look at two economies. You stack them right next to each other. You have economy A and economy B. And you decide which economy can produce the most amount of output in a given day, month, hour, etc. So some economies you might say, okay, the economy A can produce 10 chairs and economy B can produce 5 chairs. Economy A is going to have the absolute advantage in chair production because in that one day, they're producing more chairs. But there's another way to look at absolute advantage, and that's when you're looking at an input related question. And that would be how many resources of production an economy needs to devote to the production of a good to create it. So using the same numbers, 10 and 5, what if we said in economy A, it takes 10 workers to assemble a chair, and in economy B, it takes 5 workers to assemble a chair? We're going to say that economy B has an absolute advantage in chair production because they're going to be able to produce more chairs over time because it takes them half the resources, 5 versus 10. So the full definition of absolute advantage is the producer that can produce the most output or the producer that requires the least amount of inputs. And those are our resources of production. So we just talked about workers, that was labor. It could also be land, how much land goes into the production of, a good like let's say wheat or corn or broccoli, or capital, how many factories does it take? So that's our absolute advantage. These are real simple. Those we can look at real quick and go, oh, absolute advantage. Comparative advantage is going to take a little bit of work because we're going to have to solve out for what's called per unit opportunity cost. We're going to compare two economies and see who can produce a good with the least amount of stuff given up. So we're going to see who can produce a good with the lowest opportunity cost. And to do that, we're going to have to, like I said, solve for per unit opportunity cost. I meant to have this have custom animations, but blam, here's a very overwhelming slide all at once. We have two economies here. We have the golden arches of Ronald McDonald Land, and we have the sweet smelling garlic dipping sauce economy of Papa John's Pizza. Clearly, I'm just messing with you guys again because it's almost lunchtime. So in one day, Ronald McDonald can produce 20 pizzas or 200 burgers. In the same amount of time, in one day, Papa John can produce 100 pizzas or 200 burgers. If we want to determine who has the absolute advantage, we say, okay, is this an output or an input question? Well, we're talking about one day and who can produce. So production indicates output, and since it's one day as a measurement, we're going to say this is an output question. Who produces more pizza? Well, Papa John. Papa John produces 100 to Ronald McDonald's 20. So absolute advantage here is going to Papa John. Simple, painless. What about, oh, you're presenting the wrong, oh man, I was? That whole time I was talking about absolute advantage, comparative advantage, and then I wasn't even reading the chat and I'm recording this? Man, failure of a teacher. All right, let's keep it going. Let's see how many more errors I can make. Thanks for the help on that one, homie. What about burgers? So you got Ronald McDonald producing 200 burgers. You got Papa John producing 200 burgers. It's the same, so there's no absolute advantage in burgers. If Ronald McDonald made 201 burgers and Papa John had 200, then we'd say good old Ronald McDonald had the absolute advantage. But for this one, we would just say none. But how do we compare out our comparative advantage? Well, all we know is what he can produce in one day. 200 pizzas, or sorry, 20 pizzas or 200 burgers. We know that he can produce 20 pizzas and his opportunity cost is 200 burgers. And if he is producing burgers, his opportunity cost is the 20 pizzas. So if we want to break it down to make these comparable, we have to use per unit opportunity cost. And so the equation up here is the opportunity cost over the units gained. And we're just going to have to use the maximums because that's all we have to work with. So if I want to find out what the cost of one pizza is in terms of burgers, I'm going to take the total amount of burgers given up, because the opportunity cost of a pizza is burgers, and I'm going to divide it by the units gained, which is the total amount of pizzas that are made. So in this case, one pizza is going to cost the production of 10 burgers. So every time Ronald McDonald makes one pizza, he gives up the opportunity to make 10 burgers. So we'll say that the opportunity cost of one pizza is 10 burgers. And then you just flip it for the burger. Every time you make burgers, so we're making 200 burgers, you're giving up 20 pizzas. So we throw the opportunity cost over our units gained. And so in this case, every time Ronald McDonald makes a burger, he gives up a slice of pizza, 1/10 of a pizza. And you can always check your answers to make sure you're on the right track. They'll be reciprocals of one another. Now, so far we're good. We got the comparative advantage, the per unit opportunity cost of Ronald McDonald, but we can't compare against each other until we solve it out for Papa John as well. So on the bottom, I'm going to do the same exact thing, but I'm working with the numbers for Papa John. Papa John, when he's making pizzas, he can make 100 during the day. His opportunity cost is making the 200 burgers for the day. We want to know the per unit. So pizza, you give up burgers. So 200 burgers divided by the 100 pizzas. Every time that Papa John's makes a pizza, he gives up 2 burgers. Or the other way to say it is the opportunity cost of one pizza is 2 burgers. And then flip it to solve for burgers. The opportunity cost of a burger is a pizza. Throw your total number of pizzas, divide it by your total number of burgers. And now we know the opportunity cost of one burger is half a pizza. So now we can compare them out and see who has the comparative advantage. So if we want to start off with, when we start off with pizza, every time Ronald McDonald makes a pizza, he gives up 10. Every time Papa John makes a pizza, he gives up 2. So it's cheaper in terms of burgers for Papa John to make pizzas because he gives up less burgers. So we'll say that Papa John has the comparative advantage in pizza. If these two guys were willing to trade with one another, maybe Papa John says, hey, why don't I make burgers? Because Papa John might say, why don't I make pizza? Because whenever I make a pizza, I give up less burgers. God, did that sentence just fall apart or what? And then on the flip side, Ronald McDonald, whenever he makes a burger, he gives up a slice of pizza versus every time Papa John makes a burger, he gives up half a pizza. This one is way cheaper in terms of pizza. So Ronald McDonald would focus on making burgers. He has the comparative advantage in burgers. Eh? Mer? Me? Okay. So how else might this information be presented to us? We could get it in a production possibility curve. So in this case, what I'm looking at over here is the same exact thing. Instead of using the words 20 pizza or 200 burgers and 100 pizzas and 200 burgers, I just put two PPC curves onto one chart. So Papa John's, we got 100 and 200, and Ronald McDonald, we got 20 and 200. So that's our PPC curve. And then you could also use a table. And so oftentimes a table might be a lot easier too. And I'll show you how to solve with a table in the next slide. But we're just looking at the maximums. We got 100 and 200. We've got 20 and 200. So we never know how the AP exam is going to evaluate us. They could put it in a graph. They could put it in a table. They could even do an extensive table where they put all the combinations along the way. We just look at where it intersects our axes. So here's a situation. We could have in 1 month, country A can produce 30 tons of food or 10 tons of clothes. In the same amount of time, country B can produce 10 tons of food and 20 tons of clothes. So we can solve out each one of those per unit opportunity costs to determine our responses, but that could take a lot of time. Why not just drop it in a table? So over here, if we just drop this bad boy in a table, we can easily compare between the two, especially for absolute advantage. So as we're talking about 1 month, they can produce, so produce indicates output, and the constant is the amount of time. So we know this is an output question. So we'll say, all right, country A, they can produce 30 tons of food. They have the absolute advantage in food production. Country B, they can produce 20 to country A's 10. There's our other absolute advantage. But to solve for our per unit opportunity cost, this table is way more effective. We can still use the same equation. We can say units opportunity cost over units gained, but just use the table for it. If I want to find out my per unit opportunity cost of food, I'm going to say, all right, when I produce food, I give up 10 tons of clothes. Take that 10, just drop it over here in the table. When I produce clothes, oh wait, no, I have the actual answer right here for you. There we go. So in this case, every time you produce 1 ton of food, it's going to cost 1/3 a ton of clothes. If I want to solve for per unit opportunity cost of clothes, let's say, all right, when I make clothes, what's my opportunity cost? Food, take that 30, bloop, drop that puppy over on top. And now we can say that every time you produce a ton of clothes, you give up 3 tons of food. So the opportunity cost of 1 ton of clothes is 3 tons of food. So we've solved out for country A. We'll do the same thing for country B. Oh, also, make sure you double check. If it's a reciprocal, you got it right. Country B, if I want to find the per unit opportunity cost of food, what do I give up? I give up clothes. So I'm going to take that clothes, drop it on top. Opportunity cost over units gained. For every ton of food in country B, I give up 2 tons of clothes. To solve on this side, every time I make clothes, I give up food. I'm going to take this food right here, throw it right over the clothes, the units gained. Now I've got 1 ton of clothes is going to cost half a ton of food. And so now I can just compare right up and say, okay, who has the comparative advantage in food? Who can make food at the lower opportunity cost in terms of clothes? Country A. Every time they make 1 ton of food, they only give up 1/3 of a ton of clothes, whereas country B gives up 2. So country A has our advantage in food, comparative advantage in food. For clothes, let's compare down the road. Every time country A makes a ton of clothes, they give up 3 tons of food, whereas country B, for every ton of clothes, they give up half a ton of food. Half is definitely smaller than 3, so we're going to say our comparative advantage in clothes goes to country B. And since this is going to set us up for trade, it's always going to be the opposite. One of them will have the comparative advantage, and the other one will also have the comparative advantage. You can have 2 economies where one country has absolute advantage in both comparative advantage. It's always going to be flip-flopped. because it's going to set us up for a trade question. So that's a second way to check your answers. How we doing? Making sense so far? Sweet. All right, so let's keep this going. Got a little notification just popped up. Go away, little friend. All right, so what I thought we would do to handle practicing this is we'll hit up some breakout rooms. I've got 3 scenarios for you. You have one where I created a word problem. You got Owen Stan can produce 50 items of camping gear or 25 bikes, while Cornforthland can produce 90 items of camping gear or 30 bikes. And then, whoop, second question, I made a production possibility curve with trains and planes, evaluating CCA's production possibility curve and Torrey Pines production possibility curve. We'll solve for absolute advantage and comparative advantage again. And the third one's our challenge question. What we got for this one is an entire table. Let's see if we can figure out how we can compare this one out. So absolute advantage in donuts and bagels, VGs versus Einsteins. Let me set up the breakout rooms. Set them up. We want, let's go with 4 breakout. Let's go with 5 so we keep the numbers relatively small. So we're going to go with 5 breakout rooms. I'm going to open these bad boys up. It's 12 o'clock right now. Let's have everybody back at 12:15. Sound like a plan? All right, sending them out. Go get them. We got Owen Stan and Cornforthland, and we're producing camping gear and bikes. So who had the absolute advantage in camping gear? Well, that one went to Cornforth on both of them because he can produce 90 to my 50, and he can produce 30 bikes to my 25. Why? Because Cornforth is the boss. And so he's got absolute advantage in both. Who has a comparative advantage in camping gear? We're going to go Cornforth on that one. So Cornforth had a lower opportunity cost for camping gear. Every time he produced one item of camping gear, he gave up a third of a bike, whereas every time I tried, I gave up half a bike. So he had a lower opportunity cost for camping gear. And then as far as bikes go, I'm going to hold the comparative advantage in bike production because every time I build a bike, I give up the ability to make 2 goods of camping gear, whereas every time Cornforth makes a bike, he gives up 3 items of camping gear. So I hold the comparative advantage for bikes. Cornforth held it for camping gear. We all on board with that one? Sweet. All right. That brings us to the next one. Go over here. And we have a production possibility curve. So here we're going to use the intersections on our axes. Absolute advantage in trains, that's going to go to CCA. Absolute advantage in planes, nada. Nobody had it because we both produced the same amount, 50. So I would just say none. Who has the comparative advantage in trains? For this one, I went CCA. Every time they produce one train, they give up 1/4 of an airplane. Whereas when we produce one train, we give up half an airplane. So they're going to hold the comparative advantage in trains. And as far as airplanes go, every time we have the comparative advantage in airplanes because every time we build one airplane, we give up 2 trains. Whereas every time CCA makes one airplane, they give up 4 trains. So comparative advantage to Torrey Pines in airplanes. Still good with that one? Cool. The last one, you get this table. Now, we don't care about these combinations along the way. So that's why I called it challenge question, because you have to sift through all of this stuff right here. What we're going to look at is VGs can make 10 donuts or 5 bagels. Einsteins can make 6 donuts or 30 bagels for Einsteins. I don't know if I said Einsteins or VGs at this point. Either way, I'm starving. So who has the absolute advantage in donuts? We're going VGs. Who has the absolute advantage in bagels? We're going Einsteins. And then with comparative advantage, I should sure hope that VGs has a comparative advantage. And they do. Every time VGs makes a donut, they give up half a bagel. Whereas if Einstein tries to make one donut, they give up 5 bagels. So the lower opportunity cost goes to VGs, and they have the comparative advantage in donuts. Einstein's will have the comparative advantage in bagels because every time Einstein's makes one bagel, they give up a fifth of a donut, whereas VG's, every time they make a bagel, they give up two whole donuts. So the comparative advantage will go to Einstein's on that one. And again, you can kind of check your work on that one. The comparative advantages will always be opposite. Comments, questions, concerns on any of that? Nay? All right, well, let's keep moving. So this brings us to an input question. So the input question, if we remember from the intro, with an input question, that's going to be a little bit different. We're going to have one good or service. That's going to be the constant. What changes in an input question is the amount of resources that go into the production of that good or service. So into the production input. In this case, the good or service is the labor of the product, which is the AP Calc assignment or the AP Physics assignment. In this assignment, in this question, we're going to say, Joe can complete an AP Calc assignment in 2 hours and an AP Physics assignment in 4 hours. Bob can complete an AP Calc assignment in 1 hour and an AP Physics assignment in 3 hours. So the resource of production this time is labor. So Joe and Bob are laboring to create that product. And the hours are the input of labor going into that production. So we want to find the person that can do it at the lowest amount of resources, in which case Bob's going to win them both because it takes him 2 hours to do a calc assignment, whereas it's going to take Bob's going to have the comparative because it's going to take him 1 hour to complete the calc assignment versus Joe, who can do it in 2 hours, and Bob can get his physics assignments done in 3 hours, where it takes Joe 4 hours. So since Bob can do it faster over the course of a day, he's going to be able to complete more, less inputs of production. But comparative advantage, what the deuce? How do I solve for this? So one way to do it, I was about to say the easy, but the tedious way, is to convert this over to the number of assignments in a 24-hour period, because then we can take that input question and turn it into an output question. So if I set up a table to get all those words out of it, because once you get the words in, you can already see I was confusing myself with Joe and Bob. Let's just put it in the table. So we got Joe and Bob. We put our economies on the left. We put our product or good or service on the top. Calc assignment, physics assignment. Joe's got 2 hours and 4 hours, 1 hour and 3 hours. So why not just convert this bad boy over into a 24-hour workday? Well, given no breaks, no food, no nothing. It's a pretty sad reality. How many AP Calc assignments can Joe complete in a 24-hour period of time? 12. So he can make 12 assignments or complete 12 assignments in that block of time. And at 4 hours for physics, he can get 6 of those assignments done in 24 hours. Bob, on the other hand, it only takes him an hour to complete that calc assignment. In 24 hours, he can get 24 assignments done. And in physics, 3 hours to complete a physics assignment. So it's going to have 8 assignments come out of that 24-hour period of time. So what I did here was I just took this input question and I turned it into an output question. And now I can just solve it over. Just like I would do with an output question, I put the opportunity cost over. And now I would say, okay, I compare right down the middle and say, all right, well, Bob is going to have the comparative advantage in completing physics assignments and calculus assignments because every time he completes one calculus assignment, he gives up a third of a physics assignment. And then on the flip side, who has the comparative advantage in physics assignments? We're going Joe on this one because every time he completes one physics assignment, he gives up the ability to complete 2 calc assignments, whereas Bob gives up 3. So comparative advantage here is going to go to Joe. And I'll give you guys a second if you want to copy that down. All right, we're almost done. Now this seems tedious and long, and I wouldn't want to do this and convert over. So the table approach will also work for an input. We just have to switch it. Oh, I'm sorry. Anyone need more time with this? Sweet. We just have to switch it. And there isn't really an equation used for it, so I'm using my own words on this one. So if it's not 100%, bear with me. Just hear me out here. To determine per unit opportunity cost of an input, you're going to take the number of inputs required for your selected product and divide it by the number of inputs required for the product you're giving up, like your opportunity cost. So basically, I'm just switching them. So in this case, I use the acronym input question. The input question, the opportunity cost, or the other, goes under. So in this case, if I want to find the per unit opportunity cost over here, I'm just going to take the 4 hours that I would have that would have been required to complete this assignment and drop it underneath. And I'll do the same vice versa. The 2 hours I would take over here, I drop it underneath. I'll apply the same down here on the bottom. If I want to find out my per unit opportunity cost of AP Calc, I'm going to bring the physics assignments, drop it under, and I'll do vice versa, bloop, and drop it under. And then again, it's going to solve out exactly the same as we had when we converted it over to a 24-hour period of time. Again, I'm going to see that Bob has the comparative advantage in Calc, and Joe has a comparative advantage in physics. So input question, just flip it. So I like to remember it, and for like on the day of the test, obviously it's open book, open note, but I just like to write OOO and IOU. If it's an output, the other goes over. If it's an input, the other goes under, and we'll have the same exact results. Hopefully on the test you have better grammar than Mr. Owen down here. So what trips up most students is determining whether it's going to be an output question or an input question. That sometimes messes with our brains a little bit. So I was going to have us go to breakout rooms, but today's a short day. Let's just come up with our own terminology here. Oh, yeah, I have this little infographic first. How do you identify output versus input question? So just in case some of us are still kind of struggling with an output question, the length of time is constant. It's going to be 1 day, 1 year, 1 month, whatever. As long as the constant is the time, and the number of products coming out of that length of time is going to be an output question. So the number of products changes, the length of time is constant. So what comes out of 1 day? 5 chairs, 2 trains, some airplanes, etc. An input question, the product or service is the constant. What goes into the production input into the constant will make it an input question. So the land, the labor, or the capital. So the number of resources is going to change. The product is the constant. Now back to this one. If you think this is an output question, let's point up. We'll give ourselves a little alien antennae. If you think this is an input question, let's go in. So let's read this puppy out first. Number caught per day. I stole this out of an old book that was like a hunting thing. It was like number shot per day. It's like, yikes, that's brutal. I'm more about maybe some photography, but then it was still kind of dark. So I was like, maybe this is like catching for a special zoo or maybe a Madagascar thing. So in one given day, Henry can catch 4 deer or 6 antelope, while John can catch 24 deer or 12 antelope. Is this an output question or is this an input question? Yeah, a bunch of little aliens right there. Look at you guys. Yeah, output question. How about months to produce one? And by produce one, I'm talking about the months it takes to produce one car and the months it takes to produce one plane. So is this an output question or is this an input question? Boom. Now you guys look like a bunch of gangsters. Like, what up? Yeah. All right, last one. This was the challenge one because there's numbers in both. I'm talking about acres. This is a measurement of land to produce 100 bushels. It's like a agricultural measurement. So how many acres does it take to produce 100 bushels of corn? Or how many acres does it take to produce 100 bushels of rice? Henry, it takes 9 acres. And 3 acres, John, it's 8 acres or 2 acres. Is this a output question or an input question? Yeah, someone's like, no, that's just me. Yep, that's an input question. So that is it for the day. Don't worry about that one. That is it for the day. What I thought I would do briefly is show you guys what the homework is. Let me drop over here. I think I put it in here. Homework. Yep. So your homework, I just took the problems that we just looked at because we've already identified if they're output or input. Let's practice doing our absolute advantage and comparative advantage. Let me share this over. So you got your number caught per day, you got your months to produce one, and you got your acres to produce 100 bushels. So we'll identify the absolute advantage and the comparative advantage in each one. I'm thinking this is going to take us about 15 minutes max, and I will see you guys on Friday. Go get a bagel or a donut.